Hello friends, I'm Joker. In today's tutorial I'm going to talk about events in a sequence. Before I start, I'm going to define what I mean by event and what I mean by sequence. So event is pretty easy, it's just a thing that happens at a definite time. I don't think I need to get into that too much. Examples of events that you might deal with in your rooms are something like an emitter going off, right? So there's a boost emitter, or a door opening. There's a door opening. Spawning an object using a spawner or a clamp. There's a bowling ball. Or blinking a light on and off, like I do in my light sequencer room. There's that. Okay. So that's what I mean when I say event. Now, when I talk about a sequence, I mean a bunch of events happening in a specific order at specific times. Okay, so I've got this one already set up. What this is just 4 samplers and of my voice just reading off the numbers 1 through 4. Now, where just now to trigger those events over there, I pressed a button. What we have here is an event sequencer that's going to send just a non-zero signal to each event, the samplers in this case, to start the event happening. And I have these output chips set up so that you'll see that signal being passed to the event, and it's only going to blink. You have to watch carefully because it's only going to blink for 1/10 of a second, which is the length of a tick in Rec Room. So here's the event, or the sequence.
2, 3, 4.
Okay, so that happened in a specific order, and if you paid attention, they happened at different times apart, they were sort of unevenly spaced, and that's on purpose because in rooms you don't always want things to happen, the same interval apart. You want them, for dramatic effect or whatever you might be doing. You might want to space them out a little bit differently. All right, so let's go to POV now. So with event sequencers, there are 3 different ways to do them. The first one is the way that most people do them, which is using delay chips. I don't like doing that, so I'm not going to teach them in a tutorial. It's probably the easiest to understand because you just sort of string them together, but I find that to be inconvenient to set up. It uses a lot of ink, and it's also buggy. So it's not my favorite way, and it's probably not the most intuitive way once you understand how to do an event sequence with a state machine. State machines are better because they're most intuitive, and that's what I'm going to explain in this tutorial. My favorite way to do my favorite way to do events in a sequence is using selectors and comparers, and that's what I'm going to talk about in the second part of this tutorial. But for now, I'm just going to talk about state machines. So let's go over here and start setting up that state machine again so I can walk you all through it. The first thing I want to talk about is, so remember to spawn a state machine. It's under other chips, second page. Just pull it right out. And I'll get these out here while I'm in the menu. We're going to do those 4 events again. So I'm going to spawn 4 states. Just 1 state for each event. And you'll see why in just a moment. But first, for a little bit of context, the classes I've taught about state machines and the other tutorials I've done about state machines mostly focus on this chip. This is what we call the state machine chip. It's sort of the main controller of all the states, and this changes depending on which state chip it's active. And what I focused on is these 3 pins, the red, green, and blue pin on the state machine itself, because these are what output the values that you can change using the states, and we've used that for a number of different things. We're not going to be talking about that today, though. In this tutorial, we're focusing on the pins that are on the state, where this is a state machine. These are called the state chips. And I'm focusing on the pins that are on these chips because they serve a totally different purpose from the red, green, and blue pin on this chip. These chips send only a true or false, and they deal basically with timing with respect to states, and I'll explain that a little bit right now. So here are some output chips I want to use for this to demonstrate what's happening. That's a little too big. Let's scale them down. Okay, that's better. Let's see if this works this time. Oh, goodness. It's been a little buggy today. Let's try that again. For real this time? Okay. So, red, green, and blue pin, or sorry, yeah, the red, green, and blue pins on the state chips. Red pin is, and I can hover just, and I'll tell you this, on enter, green pin in state, and blue pin on exit. So this is kind of similar, for those of you that know trigger zones, it's kind of similar to the red, green, and blue pins on a trigger zone. Red on enter when entering, blue when exiting, and then green is actually total currently in zone. But the idea is that it's on state chips, the green pin will send a signal while it's in the state. So it's whereas red and blue only send a pulse signal for one tick when it enters or when it exits. The green signal or the green pin continues to send a 1 while it's in the state. So why isn't this one sending a 1? Okay, you can see it blink there on exit. And let's try and get this cooperating real quick. We reset this. Okay. Sorry, I just need to manage this for a moment. There we go. Okay, that's working more as expected. So currently it's the state machine is in this first state, and the green pin is sending a signal of 1. And when it exits, I can do that by touching this trigger zone I just set up here. The blue pin's gonna blink 1 as it moves on to the rest of the states. Okay, so we can use that to set up a timed sequence of events. I'll keep that there until I'm sure I don't need it. So let's set it up like we had over there. First, I'm just gonna, name these for the sake of keeping things straight. Remember, naming doesn't actually do anything for the states. It just helps you remember what's happening. So just state 1, 2, 3, or event 1, 2, 3, 4. Okay, and number 4. All right, and now all I'm gonna do, string these together. I think get rid of that now. So in order to set up the timing, so I've gone over the red pin, the blue pin. Yeah, so we're dealing with the red pin first of all. Oops, okay. So set up the timing of these events. Get rid of those for now. What I'm gonna do is just configure the minimum time in state for each one of these state chips. That can be used for a bunch of things, like for example, the minimum time. This is a state machine hidden inside this chip. I have a minimum time in state set for this door, so it opens and it waits that minimum time, which is hopefully 5 seconds or something, and then it closes the door again. So for our purposes, for setting up a sequence of events, that's just going. The minimum time in state is going to control the timing for moving from state to state. So let's do, like I said, we could do an even interval, but that's kind of boring. So let's do something arbitrary, like, and this is in seconds. And you can do, if you need, you can do decimals. So 0.2 is 2/10 of a second, which is 2 server ticks. But let's do 1.2 seconds. Number 2, let's do 2 seconds. 3, just even second. And 4, doesn't actually matter what 4 is for the moment because it's just going to get to that state and stay there. Right now there's no way to exit, so we'll think about 4 later. But this is the reset pin on the state machine. When I'm activating this trigger zone, all it's doing is resetting it to its beginning state, and then it just goes in order. It goes to the first state you've wired to it, which is this one, number 1, and then it plays through it. So that's all I'm doing here, so that I can demonstrate the state machine running as if it had just started. So let's scale this up a little bit, actually. So now when I reset the state machine, it's going to run through the event sequence, and the output chips are going to blink, at the timing that I just configured in all of these state chips. 1, a little bit later, 1, 1, 1. Okay. And all I did was use the on enter pin of the state chips. So that's the red pin. That's mostly what you use that for. The blue pin works almost exactly the same way. It's just it sort of staggers the timing later. So instead of, you notice as soon as I touch the reset, that's when it sends the enter signal. That's because, so basically, event 1 starts at 0 seconds, and then it waits the amount of time in that chip, and then moves on to the next. Blue pin would just be, the blue pin would just mean that it waits the amount of time before the amount of time in this chip, which is what, 1.2, before sending a signal. So it'd be, and then it blinks. And you notice these happen at the same time because exiting this state is the same thing as entering this state. Okay, so that's the blue pin. Let's bring our events over so I can actually sort of make this work. Because that's what they're here for, aren't they? And they'll be useful when I explain the green pin in a second. Okay, so we've got this guy. I'll have to space these out a little bit. That's all right. Again, for demonstration, gonna get our bowling ball. Oh, this is number 1. Ooh, I'm getting mixed up here. Number 1, number 2, number 3, number 4. Okay. So for the emitter, the blue on-off pin, or the blue emit pin, sorry, it's gonna go on enter. This door is just, I'm not gonna explain why I have that here, but this is a state machine that opens the door, so that signal is gonna start that event. This is a respawner, so respawn by tag, and I have the bowling ball tagged in there. And this is blink the light, so this is just gonna send a signal to the on-off pin, and it's gonna blink the light for only 1/10 of a second. And that's our sequence of events. And that's going to start when I hit the reset button. So, emit, open door, spawn bowling ball, blink light. There. Events in a sequence. So, now I get into the not fun stuff, which is the bugs involved in the state machine. And this is why I don't like using the state machine. The bug I'm going to tell you about, alright, I can get rid of this now. The bug is for the red pin and the blue pin on these state chips, the on enter and on exit. Sometimes the signal just doesn't get sent. This never, when there's only one person in the room, like I'm alone in here now, it does always work as far as I've seen. When there's a couple more players, for whatever reason, thanks against gravity, it doesn't always want to work. So if your event's happening at the right time are really important to you, either don't use the state machine, or you can get a little creative and use the green pin instead of the red pin. And let me explain what I mean by that. This is the bug workaround I'm thinking about here. So first let's unwire all these from the red pin. I'm not sure what I'm calling this. I think it's the in-between state method or workaround. And all this is I make these chips that I have 1, 2, 3, and 4 here are the ones that take up the time. They set the timing, but they're not the ones that send the signal. The ones that send the signal are going to be extra little chips that I just kind of sneak in between the events happening. Okay, so now I need to wire these differently. All right. Yeah, let's do that. So I'm treating these in-between ones not really as state chips, but as just the signal senders. This is getting a little crowded. So now it's going to start, it's going to go through this chip, and I'm going to use the green pin to send the signal. And then it's going to go to 1, where I have so the minimum time and state here is going to be very small. I'll tell you why it's not going to be 0, but it's going to be very small. And then 1, the state 1, the purpose of it is just to wait 1.2 seconds, and then it's going to jump to 2, but before it can go to 2, it's going to jump through this one, which is going to send the signal. So let me show you exactly what I mean. All right. And as you can see, the big disadvantage of this is it uses a bunch more ink. Where we have 4 events, we're using 8 state chips to do that, and that's not insignificant. And because I like making things visual, I'm going to scale these down to sort of emphasize their less important status, because they're in between chips. Okay. So now I can use when you don't have a minimum time, let's start with 0. Yeah, when you don't have a minimum time and state, the minimum time and state is not actually 0, it's 1 tick. It just jumps into the chip and says, okay, I'm here for 1 tick, what's next? And because there's not a time it needs to wait, and it's not waiting for a signal at the signal node, it's just going to jump to the next one. But it is there for 1 tick, and that's important because we can use that 1 tick to be sort of the same as the tick where you enter the state chip that we used earlier. So I'm just going to use this green pin up here to send the emitter signal, and to that to the output chip. And then I'm going to not use anything here, because if I wanted, if I use the green pin on the actual state chips that were taking up time, then what we would have is a signal being sent for 1.2 seconds, which for an emitter might not be what you want. I can show why sometimes it is, but for a door opening, it only needs a signal to say start opening, and then any more signal than that might cause problems. So that's why I've shortened this down to 1 tick, and I'm not using the one that lasts 1.2 seconds. Okay. And after I've shown this, I will talk about the green pin, like the actual, using the green pin for what it's intended for. A little bit out of order, that's okay. Okay. So now this should act in about the same way, but if it were in a place with people, it wouldn't be quite so buggy. I wouldn't have to worry so much about bugs. Okay. Open door. Bowling ball. Blink light. Okay. So that's the same thing, but it's a little bit more bug-proof, except, this just keeps getting better, it's not quite perfect. To really make yourself safe, if you have like a bunch more people, you actually do need to turn the time up a little bit. And I've found that 0.4 seconds is a little bit safer. Usually that guarantees that you're going to get the signal sent. But again, it might cause some problems, where if you really don't want a signal to last more than 1 server tick, setting that to 0.4 seconds might be a problem. It also, if you're paying attention, it does throw off the timing a little bit. Whereas before, this state 1 was only 1.2 seconds. Now, technically, it's 1.6 seconds because it's the 0.4 plus the 1.2. And before, it was actually 1.3 because it was 1 tick plus 12 ticks. So, but this still more or less acts the same way, just with a little bit different timing. Bowling ball. Okay. So that's that. That's that bug workaround. Now let's jump back a little bit and go back to the green pin as it was meant to be used. Wire these together. Okay. So sometimes you do want the signal, you want the event to not just be a signal sent for 1 tick. You want it to last for, some amount of time. So if I hook the green pin of state 1 up to the emitter, it's actually going to, instead of just blink on when it enters, it's going to last for an entire 1.2 seconds. And then door opening, that one I just want the 1 signal, so I could use the in-between, or since it's not going to be buggy because it's just me, let me use the red pin. And then we've got the bowling ball spawned. I don't want that to last any longer than 1 tick, so I'm going to use the red pin. And then the light we can actually have turned on for, it'll just stay there once it ends. But actually, let's have it loop back to start. No, let's not worry about it. Okay. So now let's watch what that looks like. That's on for a little bit, and then the door opens. And then a bowling ball spawns, and then the light comes on and stays on. There. So that is all the ways. Yep, that is everything I wanted to talk about today. That is all the ways to do a sequence of events using a state machine. And in part 2 of this tutorial, I will show you how to do all of that totally bug-free, more reliable, using selectors and comparers. So thanks for watching this one. I'll see you in the next one.